Hello. Welcome to your favorite artist electronics, Mr. Kilter here. I am building, well, I'm testing stuff pretty much all my life. This is my electronics. I am testing. I don't believe anything, so I'm testing the shit out of it. So pretty much this is what I had here, an LED for this soldering iron. So this soldering iron, I attach it to this cube here, the wood cube with a switch here, and I attach it from this device, which is also a soldering iron, and pretty much that's it. And I don't remember, three or four LEDs here, and all they burned out. Originally I put a power LED. My intention right now is also to put a power LED. Then I back down and I use the normal LED, but for some reason it burned out as well. Probably there are, my impression is that there are spikes, most probably when I'm switching, especially when I'm switching from here, I believe. I'm not completely sure, but it's my impression that there are spikes. So this thing is having only simple LED, SMD, white LED, a resistor and a diode, and that's it. And it worked for quite some time, for a couple of months. I don't know, not many months, 2, 3, maybe 4 months. It worked fine, and one day I decided to give up, to die. And I bet it is the LED that died, not other components. Before this little thing that I'm having here, I had power LEDs that I took out from, I cut them from burned LEDs like this. I cut it out with my scissor here. Literally I cut it like this, like a little patch, and you will see it later when I will build it here. And for this, but I never used this circuit. I used other circuits before, and I was relying on resistive dropper pretty much. But I had it in mind to use a capacitive dropper. That's it here. So simplest capacitive dropper, and this is the circuit here, and some data there. These are variants, tested stuff with 3 LEDs. Usually is what I'm trying to say. 3 LEDs are optimum for this kind of capacitive dropper that I'm usually using with these values that I'm having here. It's optimum. Yeah, see, I just read here. Spikes destroys LEDs from on-off switch. So, yeah, I remember this. Even on the switch itself, I should put a capacitor to smooth out. It's like a spring. When the switch is commutating to on, when it's making the contact on, it's not like this. It's actually bouncing a little bit there, and that bouncing probably that's rapid, very fast movement, on off is creating some sort of spike probably. I'm not completely sure, but this is what I wanted to show you. This is the type of LED that I'm using, and right now I will use only one single LED. For one single LED is absolutely awesome. It's working absolutely fine. 3 LEDs are nominal. It's not too low, not too low, not too much. On 5 LEDs, I tested it with 5 LEDs. It's good enough. I believe the maximum is 5 LEDs for this type of circuit that I'm having here, and for these values that I'm using here. So this is for the B circuit, I believe. Yeah, it's in series. With that. That is the resistor for LED here. That resistor is here. This capacitor here is here. And this capacitor here, these are old data. These are before I tested, understood, and I was getting used with this circuit. But later, after having all this data here, these are very old. My first stuff that I used, my first circuits. So right now I correct some values from there. And yeah, shit. Yeah. So this is this. And I believe it's this, 1 kilo. Okay, so this is what I'm doing. I'm doing the last thing that I promised myself to do, a capacitive dropper, which is this number B, here, this guy. And I'm doing it here, and pretty much that's it, yeah. So I want to show you how I'm building this thing, how I'm making it. I'm using this heating iron, because I unplug it from here, from this device here. I have, you see, usually I'm plugging it there. I made this. It's a piece of wood and some wires, and that's it. And I can unplug it very easily from there and use it standalone for this kind of projects. When I have to make repairments, I can take it out from there. So yeah, all right. And now I have this large scissor here because I have these pads, and I will glue them. So I'm using my silicone glue. And this is a commercial glue that you can find it everywhere. You have to watch for, you see, Lipich silicone transparent. It means glue silicone. So you have to look for silicone in commerce, and it's very normal glue. It's not a fancy or specialized glue in any way, and it's a normal glue. All right. So now this is what I'm doing. This is actually used. This is a used capacitor, but it's a brand new one because I bought a couple of them and I use it only once or twice, and it's looking like it's scrapped, but of course I took it out from another circuit that I use it, but I didn't use it that much, so it's almost brand new, even if it's looking like it's scrapped right now. So now I have to prepare. Now I'm adding my burning paper here. So I am preparing the pad right now because it is overheating. as you can see, it's leaving a mark already on the paper, and I don't want to leave a mark on that paper, not as big and not as strong, because when I will come and actually link the component to it, it will be a brief, you know, it will be brief, it will not be as long as it is right now. So now it's very good, very well prepared. That's fine. By the way, these are pieces of copper that I hammered. I took it from something, I believe it was round, and I hammered it, tack, with a hammer, and I make it flat, and I cut it, and it was having some sort of shape, and I use it. You see, they are quite thick, and I usually don't use this thick copper as thick as they are right now. You know, this kind of thickness, I don't usually use it. But right now, yeah, it's good. This is a large project, it's not a small project. I mean, the spaces are quite large, the distance. And this is another scrapped copper, so I will cut it as well and use it and glue it. I didn't even measure it. I will find a way somewhere. Somewhere there, you know. But let me glue this. I hope you can see. Let me push everything that way. That away. How Americans are starting to say these days. That away instead of that way. They believe they are more American when they are saying that away. Americans, huh? So this is what I'm doing. I'm making a little ball. I'm taking it because it's quite fluid here, and I'm making it a simple ball here. And I'm putting the ball here. Actually, it's too big, and from this ball I can use for both of them, if I'm not too cheap. And now I'm just when I'm putting heat on this silicone glue, it's starting to get extremely hard. It's starting to become extremely wet, but when it's cooling down, is becoming extremely hard. So right now I'm gluing to the cardboard that little ball that I cut and I formed. Like this, and I'm overheating the pad, and I'm pressing down, and the glue actually is coming out from the pad, and this is it. Yep, it's good enough. All right, I don't think I put it correctly. I have to check it. Yeah, well, okay, I'll leave it like this. I should have put it this way around, I believe. All right, it made a little bit of stuff here, but now you see, it solidified. It got solid, and it got extremely hard. Well, not extremely, but hard enough to keep it in place. And if everything is running cold, and it is actually running cold there, it's having no reason to get out from that glue. So pretty much this is my process. This is a very cool and very easy to make circuit. It's a bit bigger. I cannot use it with the SMD components, unfortunately. I mean, I can for some, but not for the capacitor. This capacitor, it must be this big, at a certain value, you know, 104, 630 volts. Well, it has to be. I will have to test with smaller capacitors. I believe I did test with smaller capacitor in my past, but right now I totally forget what I did and what. Yeah, you see, it's perfectly fitting there. Excellent. And this is how I'm making it, like that. I like this part. Actually, I like it very much. This part when I'm bending to position and when everything is fitting as it should be. You know, this part is nice. It's cool. I don't know. I like it. It's the part that I like about electronics when I'm building stuff. So I will put it like that. Like I said, it's brief. Right now it's quite brief. I have to keep it there for a little bit because this is heat up and it will move around. But when it's cooling down, it's good. It's holding everything. And all right, good. These are two pads. I have 1, 2, 3, 4, another 5. I have to put here. Here, as you can see here, is this bridge rectifier, which is good enough, I think. And yeah, this is the position. This is the sense. It's actually having a plus and a minus on it, on the component. This is scrapped, by the way. I took it out from something else. I have brand new as well, but I'm using the scrapped ones first. So this is for a resistor there. Let me see if this guy is here. Put it like this. I'm not completely sure. Yeah, maybe like this here. Now I'm thinking where to place these large pads that I have left, and then I'll have to find something for the bottom. Okay, okay. So these two here. All right. And like this. This dimension of the pad is ideal, this large square, because if it's small, it doesn't have, it's a problem with sticking. It doesn't have too much area to stick, and it will go out, it will peel off very, very quickly. But when it's having a large area to glue, like these squares that I'm having here, they are 0.5, 0.6 wide, like that. 0.6 centimeter, meaning 6 millimeter. 6 millimeter wide, 5 millimeter wide as a square, something like that, and they are absolutely perfect. The bigger the better, of course, but the minimum should be 0.5. Actually, I used even very extremely small, but they have the tendency to fly away because the glue is too smaller area. Nah, it's not good. So now I'm doing exactly the same thing. I'm taking out a little bit of very soft glue, you see, and I'm doing this. I'm making a little ball. There it is. I'm putting it here. Yeah, this will be for the bigger pad. I have a bigger pad, I believe. Huh? I don't know. Also, it's good to clean it on this other side as well, but in this case it's okay. So this, I want it like that. Good. I get some glue here. That's a little bit of glue. I'll make another bowl because making bowls is good. See? And this is big bowl. Too big. A little bit too big. Yeah. Actually, it's good. It's good because it left a little bit behind it, I believe. Not that much. Huh? I don't want to use too much because it will get outside, When I'm pressing this pad here, it will be squished out, and it's a waste instead of staying behind him. And behind him, on its back, that's good enough. As I'm putting here. Yeah, it's not absolutely perfect there, but I don't care. I want to leave that mark that I made there, the negative and the positive. I want to leave it visible like that as I made it there. So it's a little bit up and down, but it's good enough. And now I need another tree here. And let's find something already scrapped. And then this is, I can cut it. This is from but I'm not sure how good it is here in the middle where I hammer it. Let me test it. There, exactly in the middle. I know here in the margin is good. You see? The solder is catching here. But, whoa. It looks like it's okay. It looks like it's okay. Yeah, it's good. Okay. I was not very sure if I was getting the metal, the iron, that the solder is not catching on it here where I hit it. Okay. Let me cool it down now because it's very hot. Like this. Now it's cooling down. It's cooled down. It is good. And now I will cut a couple of pieces from it. It's too thick. Can I cut it? Can I cut you? I can cut it, but very, very hard because it's having here in the middle. Yeah, the rest is okay, but there in the middle is the problem. It's a fine sheet on the margin, but in the middle is very, very strong. No problemo. All right, I managed to cut those things in pieces, and I got some mail. I got this mail. I got 4 packages. I was waiting for them, and they all came together, which is absolutely awesome. And they came in 1 month. Unbelievable. Usually they are coming in 2 months, 3 months. I had periods when they come in 5 months. But 1 month. Oh, cool. Upgraded. I upgraded stuff, which is good. And yeah, cool. So I cut this round shape into this weird shape that I'm having right now. But it doesn't matter how it's looking. All that I'm interested in is to get it there, to fit there. And yeah, it's good enough. Or like this, actually like this, like this. Like this. I want to have a square here, a corner here, because this thing will come here, will be glued. So I want it to be like that. But first I have to prepare them. So move along. Let me refill that, it's too small. And I have a couple of, these are scrapped solder, this scrap solder from boards along the ears, and I'm having the little box, and I'm adding, and voila, I have more now. All right. It's simple. It's a very simple circuit to make. Quite fun actually, but you must have patience with the pads, with making the pads and gluing the pads, and that's the whole. It's a little bit of problem. You have to get used to it, like I am. But beside that, it's perfectly okay. So this shape that I just cut it here, it was from a bulb. Let me show you. See, from here, this little round thing, I cut it, and are those. Again, I'm experimenting stuff all the time. I'm experimenting, and I'm using unconventional, very unconventional ways of doing things, because it's good to have alternatives. This is my politics. This is my mentality, and it's a Romanian mentality to have more alternatives. Better more than nothing, or only one when you get stuck, you know. Now this guy here, I will prepare them all because I only need 3 of them, I know, but okay, good. And this guy here, this guy is having a little bit of, it was a little bit hot. Yeah, I clean it up right now. Good enough. All right, so I prepared all those 4 guys. Now time to glue some of them here, and here, and the board is done. Well, for the pads. Here I have a little bit of glue that was left. Let me put it here first. And it's quite gluey, like that. That guy there, all right. This one maybe. And like I said, I want to have a square here, a square inside. All right. But you must be careful not to overheat it, because the glue will burn out, will become black, or how is it called? It will be carbonized if you burn it too much. But a little bit of heat, like I'm doing it and working fast enough, is doing the job perfectly. Trust me, it is perfect. Let's say, yeah, that's good enough. This tiny bit. That is. That's a bit. There. Like this, I want it. Can I take you like this? Like this. This is the way I want you. Okay. The interesting thing about gluing is that I can move this, I can hit it up, and I can move it around if I don't like the position like it is right now. If I wanted it a little bit more left or right or up down, I can, you know, and then leave it to heat up and to cool down, and that's it. Now I'm looking on the markings, close there, good. And it should fit here, it should fit. All right. Okay. That's one side. And now I'm having a problem of bridging. Motherfucker. I have too much solder there, and it's bridging. Alright, it's looking good. It's looking fine. I have to be sure it's not making funny business here. Alright. Yep, I like it. Excellent. Do you like it? Yeah, cool, very cool. And now another there. This time I don't care how it's placed. That is a little bit too big. Yeah, probably like that. Let me glue it here. All right. Romanian style. Do you like it? Romanian style. All right. This pad is too much there, you see? Now I'm moving it a little bit up. And I leave some space there. You see? Here, a little bit more space. And voila, how I made a little bit more space. It's very interesting. It's a floating circuit design, and it's quite good from this point of view. Here and here, and on these two are the 240 volts. Actually, I will move this a little bit more up because I want a better separation there. And some glue remained here already. You can move it around, but not too much. Here is a problem. This might, yeah, but it's a good separation there. Good enough. It's good. Okay, so here is the 240 volts, and I made as much as possible a big separation, the distance. And from here to here, I will put SIG, S-I-G. It means siguranță in my language, but in English, to translate it is it's a piece of wire, and it will blow up if stuff will be too hot, too much. You know, it's a fuse. This is a fuse made from a piece of wire, very thin piece of wire. Let me find one. Not really. I don't have left too many thin pieces of wire. I believe this will do. This will be okay. Even thinner than this. It will be good. This is a bit too thick. You see how thick it is? And even thinner. But yeah, it's good enough, I believe. This is playing the role of a fuse. One single wire. And now I'm preparing it. A little bit. Alright. Let's see. And this and that, and this is it. This is my fuse that I'm using. And if something must blow up, pretty sure this wire will blow up first. So it's a very inexpensive fuse. What I'm doing here, very inexpensive, very cheap. Unfortunately, it's the space that is eating. Well, for this circuit, but in general you can use very small. Doesn't matter how long it is. It really doesn't matter. The thickness matter, how thick it is. And right now I'm putting quite thick wire here. I'm not totally happy with this wire diameter, but it's good enough. All right. So that is the fuse here. 1 mega resistor there, a capacitor here, this capacitor here, and another resistor for the LED. I'm not sure. Yeah, okay, 1 kilo. I'll put 1 kilo there and that's it. So 1 mega here. So let's see, 1 mega. I have a lot of scrapped. No, I don't have a lot. I don't have a lot of scrapped ones. I do not have a lot of scrapped ones. But I have something. Okay, this is a bleeding resistor. What the hell? Seriously? Okay. One mega. I don't need this shit. 1 mega. Let me actually. Yeah, that's good enough. Not even this. Not this one. Let me check it. If you are indeed 1 mega, there should be 1.1. Good enough. This other one, 1.2. Okay. Really? Huh. It says there 1 mega, but 1.250 even. Okay, I will use this guy. All right. I got this idea to put every component that I have with the markings up to actually see them when I'm reading the circuit, and it's a good thing to have it like this. And I have to bend everything to fit this position being up. You know, I will probably put it like this and this here, like this. It's a problem here not to touch. That's what I'm worried. So I will put it up here. Okay. This is more. Yeah, I like it better like this. So it will stay up a little bit here. Let's check. I'll have to prepare it a little bit. Here on its leg. Good enough. Okay. Now, my city is a very cool city. It's a very quiet city, but sometimes you can hear some strange noises. It's not like the big cities. It's a very quiet one. And especially now in the summer, when everything is hot and is not cool, you know. Okay, excellent, excellent. I like it. I like it so far. So the text is barely visible, but it is there. It's telling me that is 1 mega resistor. Now I will put it up. Excellent, good. So 1 mega did that. And now here, one capacitor of 20 micro. This is my box of capacitors. This is how I put them. So it's everything here from 20 to 40, pretty much, to 39. From 10 to 19 micro. From 47 to 99 micro. So it's a range, a smaller range. And usually, you know, you find what you want in that smaller range. From 1 to 9, pretty much. And 10 here. Yeah, it was a spacing. And this is bigger, very big ones. And what I need a 20, no? 20, which is there. A 21. And not very fat. Not a bit too fat. Huh. Yeah, this one should fit the bill. 33 micro at 50 volts. Yeah, it's good enough. It's good enough. It's good. It doesn't have to be exactly 20. It can be a little bit less or more. This is having some small legs here. This is definitely scrapped from somewhere. And yeah, even smaller. I wish to be even smaller. Let me check it here. How it's fitting on my place. Yeah, it will get out from here to be like that. I don't want it. Let's see. Yeah, theoretically, yeah, this is like that, but it's extremely bent. Okay then, extremely bent like that. I should put here, and that is positive. So negative here. It's very not cool. Not cool. Let me check if I have a smaller one. Or even 47. Yeah, here it is. I find one. Yeah, this fat guy. 22. Okay. At 25 volts. Yeah, it might be okay. So usually, if it's getting out from here, it's no problem. But usually, but in this case that I'm having here, I really need it to fit in a special dimension here that I have. I'll show you. You can see it. Yeah, here. It must fit here or there. And so on this side, either like this or either like that. And I believe I will put it like this. And if something will get out from that, I don't like it. So unfortunately, I cannot see the value on this one if I'm turning it this way. Like I said, I'm usually putting the value up to see it from without taking out the component, you know, like this. But it's not working all the time like that. Okay, I'm leaving a little bit of distance here, not to touch the aluminum case. In any case, you know, in any case. So this is fitting absolutely perfectly there. Excellent. I have to bend them down, these legs, a little bit down. And they're too short, but I believe it will be okay. I believe it will be all right. Okay, like that. I believe this capacitor here is not absolutely necessary, really, but it might protect a little bit longer, you know, from spikes. I hope. I really hope. Yeah, it's good enough. It's good enough. That's why it's good to have a lot of scrapped components and various shapes and forms. And all that I have to put now is 1 kilo, and that's it. And 1 kilo, I have a ton of them scrapped. I have quite a bunch of them. Let's see, I have a longer one this way, but I want to get rid of it for a very long time. These are very good, these guys. I really like them. This is for the LED itself. And I might change this resistor. This is an odd resistor that I have. Yeah, like this. Ta-da! I find you. Why I'm saying it's odd, because it's having flat. You see, it's a flat. It's very old. And I believe this is wired. It's like a wire. It's 1 kilo. Alright. but only one I have like this. It's from military, you know, I guess. It even has a specific smell. Right now when I'm heating it up, it's smelling different from the other components that I have. The pod is moving a little bit, but it's okay. This is it. This is the circuit. I love it. I love it. I hope it will not make boom when I will plug it in. And this should be more. This should be better than what I had until now. So these 2 points. This is positive and this is the negative. And from here it will go to the LED itself. And from here it will be the 240 volts, mains, wires, and that's it. And this is a single wire that is a fuse. All right, it's good enough. And I will make a little case. You know, I'll make a square case to protect from my finger. When I will put my finger, I will touch it by mistake there, and I will make a case, and it will be all right. So as you can see, it's a piece of cardboard. There's nothing special what I have here. All right. Do you like it? I like it. Okay, I'll come back when I will put the LED, and probably when I will mount it there. I will see. I'll have to find a way to mount it there, actually. I didn't think of it. But this is what I wanted to show you, how I'm putting these pads, how I'm gluing them, how I'm putting the components, how I'm fitting them, and how I'm building pretty much a board, a circuit board, with cardboard, and with scrapped pieces that you can solder, pretty much. That's the entire philosophy and mentality that I have. It's a Romanian mentality, remember that. Hi. All right, thank you very much. And as you can see, all this entire board that I just made, it must fit this side that I have here. This is not is loose here, it's not strong fit. This is the 240 volts main, one wire, and this is the other wire. So here is 240 volts, and of course it's unplugged right now. So this is fitting absolutely perfectly here, and I'll have to make a case and some modality to catch it. Probably glue it here. I don't know. So it should be here, and from here it will be the wires for the LED, and the LED sticking up there, and that's it. I wanted to show you the area where I'm putting it. This is a good idea, a genius idea actually. What I did, I took one board like this, which is having the aluminum plate and everything, you know, and I use that green cutter, and I cut it like that, and actually I cut it like this, only pack, you know, exactly like you're seeing here, like I leave like 2 ears beside the LED. This is very good idea that I had, and I just took out one LED from there, and I'm using it. I'm preparing it for my board here, and I have these 2 pads, one on each side, and yeah, that's what I wanted to show you. This way of cutting the LED and leaving those ears left and right for positive and negative. Sometimes they are not equal. Sometimes it's a very thin, a little bit there, and too much on the other side. But it really doesn't matter. I just tested it, this one in particular, and at around 7 volts, DC is lighting up extremely bright. On this, some are a little bit burned, but they are still working. They are still lighting up. So the voltage doesn't matter in this circuit. That really doesn't matter. The voltage, all this circuit is doing, it is lowering down the current. So it's driving the LED through a very limited current. I'm not sure how much current it will be here. Probably 30 milliamps or less, 10 milliamps maybe. I'm not sure. Remember, these are power LEDs, and they need more voltage per LED. 8 volts. 7 volts, 8 volts. Some LEDs they need even bigger voltage, like 40 volts or 30 volts. But the current is limited for all of them. So it doesn't matter the voltage, only the current is limited and actually driving the LED itself. All right. I just finished the board. I took out an LED. And I tested it with the positive and negative from my power supply here, and the voltage as well. And I find with this occasion with my power supply, I find which is the positive and which is the negative, because it is polarized. It needs positive and negative, the LED itself. And I link it there when I put 2 wires here, just to make a test how it's working. And it's working fine with my very small, this wire that is made specifically for tests. And yeah, it's working okay. It's working fine, and it's very, very bright, and I love it. I love this very bright LEDs. They are. It's very easy to see them, even if it's somewhere there, with my tail of my eye, with my peripheral view, of my eye, I can see it there lighting up, and it's good. It's very, very good, so bright and intense, and yeah, that's why I'm after this power LEDs to use them, because they are good signaling LEDs. You can see them from a very long distance, or when I'm working, I'm not actually looking with my eyes on it when it's staying there. I'm looking somewhere here or here, and it's enough to see it with my peripheral view. I see its brightness, and yeah, it's I know this iron is plugged in, and it's in contact pretty much, and it's hot. Yeah, this is the test what I'm having here, and oh yeah, I'm very pleased with it. I hope you like it. This is the circuit, as you can see there. There is the diagram. I'm moving closer for you to see it. I actually corrected it because this was a very old circuit with the data in it, very old, but now I know it by heart. I built it quite some many times. I built this circuit actually, and I know the values by heart now. And also I have specific values, specific components already that I'm actually using, specifically, especially this capacitor. This red one that I'm having there is this guy here with 1 mega across it, and this capacitor here, I don't actually put it every time. I was experimenting, but it's good for spikes, I hope. And the 1 kilo resistor there for the LED itself. Sometimes it doesn't need it. Sometimes it does. Yeah, well, it's good enough. I'm happy with it. I'll have to check for the temperature actually to see how hot things are, and then I will assemble it here, and the job is done. Like I said, I am experimenting a lot, so nothing in my channel is per se. I mean, you have to take it with a bit of salt. Everything I'm saying, you have to think for yourself. You have to adapt things on your side, depending on what components you have to adapt. But the main idea, the basic idea, is what I'm presenting here. Hopefully, I hope I'm presenting some basic ideas, because I'm very easily going into too complex things, and stuff gets ugly after that. Okay. That's it for this part, and I will film when I will put it there. All right, see you later. So now I am thinking on making the box, and this is how I'm making it on a scrap piece of paper. I don't care. I really don't care what is here. It's just a scrap piece of paper, and I'm imagining how the box should look and feel, and how I wanted it to be, and how complex is this thing, and how to make it work. So this is the back here. Is the back where this side will stay onto it. Okay. So all the components like you are seeing right now, it will stay here in the middle, and then it will have one side lift up, another the same height as this one is on the other side as this. So I don't know how to show you. So I'm making an exercise of imagination how it should look, everything. And this is the top, the cap, the top lid, like a lid. Okay, the top lid that it will cover everything here. This part here is the top lid, and this is the same as this two here. Is the height, and it will be glued on this other side. When everything will be folded together, it will reach that side as well. It will overlap this side, and I will put some glue here and here, and that's it. I will make it as a box, and then I want to also protect the 240 volts, especially this area, to protect it from my finger. I mean, if I'm touching with my finger, I don't want to mistakenly touch it by mistake, and I want to have a little bit of protection. And I put 2 ears, 1 ear up, as the height is as this other ones here. This and this is the same height here and here, and then like a ear that will be folded on the top of the box here, and it will be I will put a little bit of scotch of and that's it. This, or even longer probably, it will be best, and this is the idea. Actually, every line matters here. So I will make it more clear like this, so this ear will be actually, and everything will slide, this entire thing. After I will glue it there, it will slide on and off like this, like this, back and back, and the entire board. And these 2 ears will be folded on top of it, and that's it. These wires probably will get on the corners here. They will get out, and also these ones as well on the corner here and here, to actually be able to fold this on top and have no problems. And that's it. It will be a compact box. It will be perfect as a box. Perfect as I wanted it to be. That's the point. And right now I already prepared a piece of paper here, cardboard, yeah. And I've already I've already measured the height of the thing, and it's having 6 millimeter. And I'm drawing it by eye. I don't really care if it's a little bit more or less. It's okay, because it's cardboard and it is squishing and it's forming as I want it. To have a rough dimension, to everything to be rough there, and it's good enough. I'm doing it by eye. I hope I can use it until here. So here it will be also 6. And now is the moment of truth. 1.9. 1.9. Let's see. Yep, it's good enough. Good. At the limit, which is good. And this part will be glued on that part. And it's not perfect here. Probably it will be in interior. This will stay in interior, and that good part will stay in exterior. Yeah, it's good enough. I wanted it to put it like this because I'm not sure how much I will leave here. So I will leave, let's see, from here and here. And I choose this side because it's having some patterns here from the other side, the chocolate. And those patterns, really, I don't care for this type of box that I'm making, because it will not be seen. It's under here, is underneath it, and it's doesn't matter how it is. So let's see. This will be also 6. Also a little bit of tolerance, 1 millimeter, because it will be bent. And also here I should have think. Yeah, it will be squeezed a little bit then. And then probably this, yeah, how long it will be. let's see, 1.9. And here, yeah, it's good until here. It doesn't matter. Actually, I can take this 1.5, 1.5 to be the same. Okay, good enough, good enough. And well, this is not too straight. Now it's better. And this is 6, and here is also 6. So only this part will bend, only this square, and here as well. I think, yeah, good enough. All right, let's proceed with cutting. Everything is laid down. I know exactly what I have to do. All right. And yeah, okay. It's very nice to make boxes. I like it. I'm not really like it. It's not the only pleasure that I have, but it is nice to make boxes. Actually, it's not a. When I was little, well, when I was having 10 years old probably, and I saw a plane made with sticks, with very thin sticks, wood sticks, and I'm also checking how it should look here, and it is looking like that there. And also paper, cardboard, and I didn't have the money back then. I was too little, and I asked my parents, and they say, no, we don't have money to spend on bullshit, but on toys. And it remained with me, that toy made from cardboard and sticks and wood sticks, and it was nice. Or I believe I actually bought it. I don't remember exactly what I did. I believe I bought it. It was not that expensive. I believe I managed to make the money, and it will have some pattern here. It will have some. Yeah, it will be okay. But it remained this kind of pleasure of. It was an idea of making from cardboard, pretty much everything you want. You know, the cardboard is a very it's taken by granted. You know, you're taking it by granted. Yeah, whatever. Yeah, you see, and this side will be stick. I will stick it to this side, and this is the box. You see it? Can you see it now? And of course, I will have to take care of those wires because right now, but it is fitting perfectly there, and it's not bending. You know, it is as it should be. It's quite a press fit. It will be press fit there. I should take out those wires now, and I have to let it hit up. Until then, I have time to bend it into its place. Yeah, this will be in interior, this side, which is a bit more uglier. I don't care, but it's a surface that I can use to glue. It will be like this. And I have to clean it a little bit. These high spots that I have there. Yeah, good enough. Good enough. It will be like this, you know. It's looking like a tiny chocolate box. Yeah, I can actually glue it like this as well because it's really not that bad on this side either, huh? Or not? No, I'll leave it like this. All right. All right. So I put the glue here. I was thinking right now to add metallic caps, you know, like you're using for paper caps, but I don't think it's a good idea because it's metal, and I don't want to short stuff here. You know, like this is like a tiny bit of piece of metal, and then it's bended down like this. It's bended down, so it will look in the end. It will look like this. It's bended and it's catching very strong, but it is metal and is having the possibility to short stuff, and I don't want to short stuff. It's not really a good idea right now. So glue should be, the glue that I'm putting right now here should be enough, should be good enough, you know. Now I'm checking from every angle to be okay. And it's not looking bad here either. Probably here a little bit. I can correct it very quickly. Yeah, whatever. It's having flowers. It's very beautiful. It's looking like a tiny chocolate, you know. And yeah, it's good. It's nice. I like it. So this thing will slide like this. You see? Ta-da! Yeah. All right. But now is catching in those strong wire here. It's quite strong. And okay, my iron is hit up. And of course, I will not use these wires that I'm having right now. So I I put a new wire, this brown wire here. I had to take out everything there, all this ensemble there, and take it out and put a new wire here, longer. This was very long wire, but I started to take out the screws to replace with the idea to replace this white wire that I'm having. It was very long, but then I got the idea to push it back, the wire inside, and I put back everything, so it's good enough as it is. So this is how it will look, and I also changed the wires that they were before. So I managed to make it work. I actually made a small mistake. I made when it was down, it was on, and when the switch were up, was off. So all that I had to do was to turn around this piece of sheet metal that I'm having here to 180 degrees to the other side pretty much, and rotate everything. And now when it's up like it is now, it's turning on, and when it's down, it's turning off as it was before. It's exactly the same, and it's exactly the same as this button as well. When it's like this is off, and when it's like this is on. And now the only thing that I have to deal with is how to catch it to this block of wood, because as you can see, it's trembling there, is catching into these wires here. And I had I took out everything, and I soldered the new wire, this brown wire, and I drag it and I changed the positions, I believe 2 times. I desoldered it and resoldered it again, switching the pads, and yep, this long wire, this long white wire was very long, and I pushed it back inside, and it was a good idea to do it like that, to preserve it and not to cut it to the exact length. And now all that I have left is to somehow catch this box to this screw that is already there, that is holding the switch. By the way, I made this little piece of metal and I screwed it. It's not that hard, but it's looking quite professional looking, you know. It's looking like it's made by NASA or Panasonic or something, but in reality it's made from in Romania by your favorite Q12 here. So all that remains right now is to catch this box to this cube, and the project is finished. See you later. And I find a solution. A piece of cardboard. I just put some glue only on this side here, and I glue it very firmly right now, and I'm waiting for it to dry out, because right now it's very liquid, and I have to give it some time to harden. And I will take out this cardboard will go under that, and pretty much this entire setup, what I'm having here, it will squeeze this little cardboard that will hold this little box pretty much. And so I'm trusting absolutely into the glue. Here is a very large surface, and the adherence is very good. And this is the solution that I find. Very cheap, very easy to do. And see you later. Right, said and done. Everything is powered. This is powered, but I don't want to charge it up. Here is not connected to anything yet, but I managed to put this is a little bit flimsy here, but it doesn't matter, because I don't really have, if something will bother me in the future, I will make it more sturdier catched to this cube. But for now, this little thing that I did today should be okay. So now when I'm powering it up, I'm not sure in the video if it will flicker, but in reality it's not flickery, but it's very bright. It's super bright, and yeah, that's exactly what I really wanted. And this is it. So here it is, at my hand. As you can see, this LCD is not showing anything because it's not unplugged. But when I'm switching here, this very bright LED is lighting up, and the LCD is showing some numbers there. You see there, and yeah, like I said before, all the LEDs that I put before, they burned out for some reason. Overheating, the LED was overheating, or the resistor, or the diode, whatever it was. I had it with this SMD components like I'm having it here, and I tried my best to make it work, but for some reason I didn't like it. I should actually put a capacitor on the switch itself. I will have to check it, to put a capacitor directly on the switch, on the contacts of the switch. I should. I'm not really used to do it, but I know it's a good measure, or at least in the input inside the box here, inside this little box that I made. But job done, and yeah, I waited a couple of days. It actually waited for me a couple of days to get to it, and now I just did it, and I'm very happy, and I hope it will last, because this was the last secure way of, or sure. This is not an experiment as much as experimental as the others were. So I'm trusting very much this circuit that I'm having right now, not to destroy itself or the LED, the power LED that is right now there. The biggest disadvantage of this circuit that I'm having right now is it is too big. But other than that, it should be more, it should last me years. It shouldn't burn out anything from now on. This is what I'm expecting, but we will see. Time will tell. If this is the last circuit that I wanted to include it. That's why I tested, and I was playing with other circuits until this one, and yeah, I kind of screw it up with the others. I really wanted a power LED to be able to drive it with SMD components only, and I failed. And yeah, this was the last idea, the last resort, and time will tell. All right, thank you very much, and I hope you like it. Let me bring it back. Show, close it, and bye-bye.